Okay, now we're going to learn about laws of exponents and then how you would evaluate, meaning if you had an exponent power, then how do you evaluate that? Okay, so see this 3 squared here? Well, here's how you would show the work of evaluate. 3 squared means the same thing as 3 times 3, which is 9, all right? Square root of 9 means the same thing as the square root of 3 times 3, or the square root of 3 squared. Notice the square root and the exponent, those two cancel, leaving 3. Another way to write the square root of 9 is 9 to the 1/2 power. Fractional exponents means the same thing as root. So if it's 9 to the 1/2, it's square root. If it's 9 to the 1/3, it's cube root. Okay, so now we go to the laws of exponents. Laws of exponents apply when powers have the same base. So this is the base number, and this is the exponent. The whole thing is called a power. So powers with the same base, there are these laws. When you're multiplying, dividing, and raising a power to a power. So let me go ahead and erase that. So when you're multiplying powers of the same base, so notice 2 squared means the same thing as 2 times 2. 2 to the 4th means the same thing as 2 times 2 times 2 times 2. And if you count up all those 2's, 1, 2, 3, 4, 5, 6, you end up with 2 to the 6th. But an easier way to do that is when powers of the same base, look at, we can add those exponents. So a faster way would be to rewrite 2 to the 2 plus 4, which is 2 to the 6th. But that's the product rule. The bases must be the same when you're multiplying powers for the product rule to happen. All right, so for an example, what if we had 2 to the 3rd times 3 to the 5th? Can you do this? No, because these base numbers are not the same. So to evaluate this, you would say 2 to the 3rd, which is 2 times 2 times 2, which is 8, times 3 to the 5th. Well, let's see. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So to evaluate that, 2 to the 3rd is 8, 3 to the 5th is 243, and then you would simply multiply 8 times 243. Okay. The quotient rule, remember, dividing and multiplying are inverses of each other. So when we are up here at the product rule, notice when it was the product rule and you multiplied powers with the same base, you added the exponents. So because they're inverses, when you divide powers, notice the base number is the same. What's the opposite of addition? Yep, subtraction. So, and here's a visual way. 3 to the 5th is 3 times 3 times 3 times 3 times 3 over, or divide by 3 to the 4th, 3 times 3 times 3 times 3. Notice you can cancel these. And what's left? 3 to the 1st. Or an easier way, if you're just using the quotient rule, 3 to the, take the numerator exponent and subtract the denominator exponent. 5 subtract 4 is 1, so 3 to the 1st. Okay, now we're down here at power rule. When you raise a power to a power, so this whole thing is a power, and when you're raising it to a power, well, notice anytime you have a number and you're raising it, so let's say we have 2 to the 3rd, well, that means 2 times 2 times 2. Well, 4 squared to the 3rd means 4 squared times 4 squared times 4 squared. And look at what we have. We have powers of the same base. So we have 4 to the 2 plus 2 plus 2, because once we set it up like this, we can just do the product rule now. But the faster way, we'll notice 2 plus 2 plus 2 is 6, so this is 4 to the 6th. Well, what's 2 times 3? 6. So the power rule says that instead of rewriting it like this, 4 squared to the third, you can simply take the base number, when a power is being raised to a power, multiply those exponents. So 3 times 2 is 6. All right? Then we've got these special rules. The zero exponent. So any non-zero number, can't be 0, any non-zero number to the 0 exponent is equal to 1. And this is why. When you're looking at the quotient rule, look at this. 5 to the 6 divided by 5 to the 6. Well, if you apply the quotient rule, 6 subtract 6, so 6 subtract 6 is 5 to the 0. Well, that still doesn't explain why that's 1. Well, this is why. Any number divided by itself is 1. And when you apply the quotient rule, the numerator power or exponent, subtract the denominator exponent, you end up with 0. So 5 to the 0 is equal to 1. Again, it only counts when there's a non-zero number. So let's do another example. What if it's x to the 0? Yep, that equals 1. The only thing that you have to do there, the only thing that you have to do there is you have to say when x is not equal to 0. So this is true when x is not equal to 0. Here's another example. What about if you have all of these things to the 0 exponent? Yep, that whole thing is equal to 1. If you had even a bigger thing, say there was a bunch of stuff here, and each of these had exponents to them, and down here maybe they had exponents to them, but on the outside is a 0, this entire thing is equal to 1. Because remember, if you apply the raising a power to a power, you multiply the exponents. Well, 0 times 3 is 0, so we would have x to the 0, which is 1. Then we would have 4 times 0, which is y to the 0, and that's z to the first. 1 times 0 is 0, z to the 0. Well, x to the 0 is 1, times y to the 0 is 1, times z to the 0 is 1. 1 times 1 times 1 is 1. All right, quickly, negative exponents. This just tells you to turn that number to its reciprocal. So 10 to the negative 1 means the same thing as 1 over 10 to the first. So here's an example of why that's true. So let's say we have 10 to the fourth over 10 to the fifth. Well, 10 to the fourth is 10 times 10 times 10 times 10 times 1 over 10 times 10 times 10 times 10 times 10. Those all cancel, leaving you 1/10. Well, if you applied the laws of exponents, let's see if I brought that down. No, I didn't. If you apply the laws of exponents, so 10 to the fourth over 10 to the fifth is 10 to the, remember, numerator exponent subtract, you get 10 to the negative 1. Well, what did 10 to the negative 1 equal? 1 over 10, or 1 over 10 to the first. So let's look at another example. If it's a negative exponent, flip everything. So here we have x to the negative 6. You'd simply rewrite it as 1 over x to the 6th. Let's see. What if we had 1 over y to the negative 4th? Yep, you would simply rewrite that as y, because again, you still have to do the reciprocal. So flip this. This gets flipped, y to the 4th over 1, or you just can write it as y to the 4th. All right, that's it for laws of exponents.